Okay, let's continue with our ENCOR infrastructure lab. In this case, we're going to perform something that Cisco calls NAT overload. This is a particular Cisco product that combines NAT and PAT. We're going to configure that here, that this will be our first NAT overload. We are also going to have another NAT overload here. So our BRF users and guest BRF IP addresses will be able to actually get access to the internet. Now let's go for the theory first, and then we're going to do the actual lab. NAT stands for Network Address Translation. This feature actually translates IP addresses, and NAT actually works symmetrically. So for outgoing traffic, for instance, NAT is going to actually go into your packets and change the source IP address. And when this traffic comes back, NAT is going to do the symmetrical operation. So it is going to go and change the destination IP address to the original IP address that it changed in the first step. So the main usage of NAT is solving the public IPv4 address exhaustion problem that we have been having in the last 20 years. So we can blame NAT for not for still having IPv4 in our networks rather than having transition into IPv6. So the first thing, or the first approach when configuring NAT, is that you have to figure out what is the external part of your network and what is the internal part of your network. That is the best practice before configuring NAT. And a couple of examples here. For instance, your wide area network interface could be your external part of your network, and your local area network interfaces, that can be more than one, could be your internal part of your network. Another approach will be analyzing your network, and if you see public IP addressing, that will be your external part of your network that is facing into the internet, and your private IP addressing interfaces will be your internal part of your network. Notice that the threshold between internal and external is usually a router or a firewall. Some people might think that a layer 3 switch could perform NAT, but this is in most of the cases not true. Only a small percentage of layer 3 switches are able to perform NAT. The devices that usually perform NAT are routers or firewalls. Now that you have figured out what is the external part of your network, what is your internal part of your network, you are going to go and configure that IP NAT inside and IP NAT outside. On the external part of your network, which is usually one interface, you are going to configure IP NAT outside. And for the internal part of your network, that can be many interfaces, you are going to configure IP NAT inside. Now we have mainly two options to do NAT here. We're going to call option 1 the option where you are going to change your traffic that was originated internally. So for traffic that was originated from your internal network to your to some external device, we are going to call that option 1, and we are going to call that inside source. The other option that we have is changing IP address that are originated from external network into your internal network. So in this case, we're going to call that outside source. This second option is seldom used. It is still available out there to solve certain problems. You are going to use this outside source option maybe 2% of the time, and maybe you would use the inside source NAT option 98% of the time. So let's go for the first option. We are going to analyze how the NAT inside source option works. In this case, you want to change the source IP address when you want to reach an external network, for instance, the internet. So this is the most used NAT option. It is usually used in a combination with path that Cisco calls NAT overload, and it is usually used to reach the internet. Every single person that has contracted an ISP in order to reach the internet will receive a router from its ISP, and this ISP router is going to perform inside source translation, particularly with this combination with PAD. Cisco called this combination NAT overload. This is actually a marketing term for the product. Other vendors call it in other ways. So if you go and configure a Huawei device, you will not see an overload option, but you will still have a NAT plus PAT option to configure. So for instance, Huawei calls this combination of NAT and PAT with a single IP address ECIP. So Cisco calls this NAT overload. And in this case, if you want to configure this, you have to remember that you are going to use the command ipnat inside source. So let's see how inside source works. In this case, we have this user that has this IP address 192.168.1.1, and this user wants to reach this server that has this IP address 1.1.1.1. In this case, a packet will be built with this source IP address and with this destination IP address. In this case, when this packet reaches the default gateway will notice that it already has a NAT table, and for instance, that says that this source IP address should be translated into this public IP address. So when this packet gets forwarded into the internet, we are going to see that the source IP address was changed into a public routable IP address. So this server will eventually will receive this packet, and it will then try to respond. When responding, remember that devices will change the order of the IP addresses. So in this case, the source IP address becomes the destination IP address, and the original destination IP address becomes the source IP address. So this is a response packet. When this response packet reaches the same router, this router will notice that it was configured to NAT this private IP address into this public IP address. So it is noticing that it is receiving a response packet, so it has to perform the opposite function. So if you configure NAT to NAT this IP address into this IP address, then for outgoing traffic that will happen, but for incoming traffic the opposite will happen. We are going to change the destination IP address from this one to this one. So this is what NAT does, this is the behavior of NAT. It will perform these two operations symmetrically. So in the outgoing direction, it is going to change the source IP address, and in the incoming direction, it is going to change the destination IP address. Now, let's examine this second option that we talked about, which is known as the outside source. We already saw inside source, so we're going to talk about outside source. This is a seldom used NAT. It is usually used for duplicate IP addressing within your network. There is an overlap of networks. So for instance, you have configured your network 10.1.1.0/24 here, and you are using internally here your 10.1.1.0/24 network. So there is an overlapping of networks. So we are going to perform in those cases outside source translation. In order to configure that, the command changes a little. In this case is IPNAT outside source. IPNAT outside source. And then you have to learn these terms, because when issuing show commands for NAT, you will see this terminology. Inside local, inside global, outside local, and outside global. So for instance, if you're using inside source NAT translation, which is the option 1, your outside local and your outside global will be the same for option 1. They will be untouched, and you are just going to translate the inside global and inside local. So the inside local will be your actual device IP address in an internal network. So for instance, this could be a private IP address. And your inside global will be usually a public IP address that represents your user IP address in the internet. But if you went for option 2 of NAT, that means outside source, then the inside local will be usually the same as the inside global, and you will be actually changing outside local and outside global. So the outside global is the host IP address, the actual host IP address as it was configured on an external network, and the outside global is the translated IP address that represents an outside host in an internal network. So if you're using this, you are going to be instructed your device to change the outside global IP address into an outside local, and the inside local and the outside inside global will remain the same. So let's see this in detail. So let's analyze in this case inside source NAT translation, which is our option 1 in this case. Remember that the traffic is originated in the internal network and it is sent to an external network. In this case, the source IP address is changed in the outgoing direction. In this case, we are going to call this source IP address that we're changing the inside local, and the translated IP address is the inside global. The outside global and the outside local are the same. They are not touched at all. So you can see that when issuing show IP NAT translation, you will see your inside global and your inside local and your outside local and your outside global. So if you see that the outside local and the outside global are the same, this means that this is an inside source translation. Now, in the option 2, for option 2, when doing outside source, remember that this is seldom used. We're not usually using this. In this case, this NAT happens when traffic starts on an external network and it wants to reach your internal network. And in this case, you want to change the source IP address for that traffic. In this case, this is known as the outside global IP. This is known as the outside local IP. And the inside global and the inside locals remain the same. So bear that in mind. We have several types of NATs. We have one-to-one. We have many to many. We have NAT overload, that is a lot of IP address to one, or a lot to many. And we can do port forwarding. That is used when you have several services, publicly available services, using only one IP address. So let's examine this. For instance, you may want to use a static NAT. For instance, if you have one server and you have with one private IP address and you have one public IP address. So you have one public and one private. And in this case, for instance, let's say that this server is providing several services. It is providing web services, DNS services, FTP services, and it is probably remote desktop services, and so on. So you have a lot of services in the same server. It makes sense to provide this server with one complete whole public IP address to it. Otherwise, it will be a waste of public IP address. But in this case, probably makes sense. In this case, you will be using inside source NATing, which is the option 1 that we have been talking about. So we have this other example. You have this complete /24 network that you want to translate into this complete /24 network. So in this case, it makes sense to use a static NAT. For instance, you could use this translation. For instance, if you have an overlapping network. So in this case, to do this translation using a static NAT, you will be using option 2, which will be outside source. And if you have to do this in 2 directions, so you will be using for this other translation NAT inside source. So these are 2 examples where you are going to actually go and create a mapping between one IP address in the inside and one IP address in the outside. So in order to configure this, for option 1, inside source, you are going to configure IP NAT inside source static, and then your inside local IP address, for instance, your private IP address, and then your inside global IP address, that is your public IP address, for instance. And if you go for option number 2, which is outside source NAT translation, that we said that it is seldom used, you are going to go and configure IP NAT outside source, and then the parameter static, and then your outside global, and then your outside local. Notice that the order of the global and local is changed. For your option number 1 with using inside source NAT, you will first have to provide the inside local and then the inside global. And for outside source NATs, you will first have to provide the inside global and then your outside local. Now, this is an example. For instance, when you have an overlapping network in this device router 2, you will have to configure IP NAT inside source static with the parameter network. The parameter network will help you NAT complete sets of IPs. So in this case, with the parameter network, we are NATing a complete /24 network into a different /24 network. So we are NATing 10.1.1.0, which is this, into 10.200.200.0, which is this. You are NATing a set of IP addresses. So we are changing the complete set of IP addresses in just one command. With the previous command, you could only map 1 to 1. In this case, you are mapping 255 IPs to 255 IPs in one go. And remember that, given we have been saying that you would use IP NAT outside source when you have overlapping network, you will need to do this other command to perform the necessary NATing for these two networks to communicate to each other. So for this network will think that this other network is 10 to .100 to .100, and these users here will believe that this remote network is actually 10.100.100. So you're actually deceiving your users with this NAT configuration. They believe the other remote network has a different IP that what they actually are using on their devices in order to make these two overlapping prefixes to communicate to each other. Now we have an interesting feature. We have been saying that the static NAT is a one-to-one mapping. But with the extendable parameter, we can, for instance, have one IP address that maps to, for instance, two or more IP addresses. So let's say, for instance, we have this example here where you have a dual humming. So you have two ISPs, and this ISP number one provides you with the IP address 8.8.8.200, and this other ISP provides you with the IP address 9.9.200. These are both public IP address, and you have one server here that has the IP address 10.1.1.1. So you can make this a static NAT assignment where this device is NATed to this IP address and it is NATed to this IP address. So in this case, that your ISP number one goes down for some reason, you still can reach your server through this other IP address that is public. So you can use, for instance, these two commands. Remember that this is a NAT inside source, which is our option one for NATing. And this is your inside local, and these are your inside global IP address. With the command extendable, we are instructing this router that we are not performing a one-to-one but one-to-many. Now, the second option for NAT, we already saw the first option, which is a static NAT. We can also do dynamic NAT, where we can do a many to many NATs. This is seldom used. In this case, you will need a pool of available translation IP address, so you will need this pool so you can go and contract from your ISP a set of public IP address, and you are going to use them to NAT a set of servers. So you can have, for instance, this set of 8 servers that have a private IP address, and you want to map them dynamically using this set of 8 public IP addresses. So this NAT works as long as the pool of available translation IP address is not exhausted. So for instance, you can have this device, which is a load balance device that is also doing NAT, and you don't really care about exactly how NAT is going to be performed. So for instance, this is 10.1.1.1, this is .2, this is .3, this is .4, and so on. So you don't want to actually go and type that this device .1 is going to be mapped into a particular public IP address, and this device 2 is going to be mapped into a particular IP address. You just set a pool of devices that will be mapped to a pool of public IP address and let this device do the math for you. So in order to configure dynamic NAT, you will first define a pool of available public IP address, for instance. Next, you will define what addresses may be subject to NAT using an ACL. So this will be your public IP address pool. And then you will define what private IP address are able to use this pool. and then you will finally define the NAT command that connects this ASL to this pool. So for instance, in order to configure dynamic NAT following these steps, you will first define your pool using the command ipnat pool. Then you create your access control list to define what private IP addresses can use the NAT feature, and then you will issue the command to link these two settings together. ipnat inside source, then list and your ASL, and pool your pool name. So 3 steps: define your pool. Second step, define your ACL. Third step, using the command ipnat inside source, you're going to bind these two settings together. Now let's go and see the most important Cisco feature for NAT that we are going to use most of the cases, that is not as known as NAT overload, which is actually a combination of NAT and PAT, because it is not going to change only your IP address, it is going to also change your TCP or UDP port that you're using. And if you're not using a TCP or UDP port, for instance, if you're using ICMP, it is going to provide you with a TCP or UDP port as required. In order for this to work, it is going to work heavily with ports besides working with IP. So it is a good combination of NAT, network address translation, and port and PAT, port address translation. Cisco calls these features NAT overload. This is how Cisco calls this combination. For instance, Huawei has a similar solution. They call it ECIP. So it depends on the vendor. This is just the vendor name, NAT overload. This is what Cisco calls this. And you can, for instance, use this way of overloading with only one IP address, that is the IP address that lets you connect to the internet. Let's say that this IP address that connects you to the internet has a public IP address. In this case, for instance, 8.8.8.100, and you have a lot of public or private IP addresses that wants to reach the internet. For instance, 10.1.1.0/24. In this case, you have 254 users that wants to use the internet, and we are going to use only one public IP address to accommodate all their connections. This is one way of using NAT overload. If you have too many users, maybe more than 254, let's say that you have several /24 private networks, you might want to go and contract from your ISP a pool of IP addresses. So you can use this pool of IP addresses to accommodate the needs for too many users. Perhaps one IP address is not enough, because this feature has a limitation. You only have so many TCP and UDP ports. Your TCP ports and UDP ports are not infinite. There are a finite resource. So maybe only using one IP address is not enough. So you have to go to your ISP and buy several IP addresses that you are going to configure in a pool of public IP address, and then you are going to do overloading over this pool. Carriers usually use these. They have a pool of public IP address, and they use this pool in order to NAT all of their customers. When you're doing this in high scales, if you're doing this, if you're, for instance, an ISP or a carrier service provider, this is known as carrier grade NAT. So you're going to see that. CGN. So CGN happens when you have these huge pools of public IP addresses and you are using this NAT overload trick in order to provide internet access to a lot of hundreds of maybe thousands of users. But you can use it on the enterprise as well using pools. Now, NAT overload works as long as the amount of available ports is not exhausted. There are only so many ports and UDP ports for one IP address. So internally, Cisco uses this process that is known as TPM or Transport Port Manager. It is going to allocate dynamically the ports for all of this to work. By default, for one IP address, it is going to use ports from this number to this number. So this is the default range. You can go and change this range. You can change it to this if you want more ports. So just be aware of that. You can also change or say what ports you don't want this NAT overload feature to use. Perhaps you're using some particular ports, let's say this one, and you don't want NAT overload to use this port on your public IP address. You can go and configure that. So the way to configure NAT overload, for instance, is first you create an ACL to say what users will have permission to reach the internet, and then you will use the command ipnat inside source, binding the list that you just created, and then using one interface to go to the internet with the parameter overload. So when using overload, you are instructing the router to use NAT plus path. And in this case, we are going to let all of these users, including this ACL, to reach the internet through the only the IP address that is configured in this interface. So this will be a NAT from a lot of users to only one IP. So if one IP is not enough because you only have so many TCP ports, then you can create a pool and then an access control list, and then use your command ipnat inside source to bind this list to this pool with the parameter overload. This is quite similar to dynamic NAT, but in this case, if we add this parameter overload, then this stops being dynamic NAT and it becomes NAT overload. Now, the final option for NAT that you have available in this session that we're going to talk in this session is port forwarding. Port forwarding is also using path. In this case, you only have one IP address, one static IP address. Remember that you have several options with your ISP. You can buy a dynamic public IP address. This costs some money, but you can go and buy a static public IP address. This costs a little bit more of money, but you can rent that and just be sure that every time that you turn on this device, it is going to acquire the same public IP address, let's say 8.8.8.100. Your ISP is going to make sure that this device always is able to use this IP address. And when having only one public IP address, you can publish as many device public services as you want, because you're going to also make use of ports. When using path, then you can use all your 65,000 TCP and UDP ports. So in theory, using port forwarding, you could actually publish this amount of services, public IP services, in using only one IP. So for instance, let's say that you have these servers in your enterprise, and you have one web server, one DNS server, FTP servers, and one SMTP server, and you also want to reach your computers using RDP, remote desktop protocol. So it is possible. If you have one static public IP address, you will have to configure port forwarding. Port forwarding translates in a one-to-one basis per port, allowing users on external networks to access specific services on internal networks. So you can go and add this mapping within this device, so you can let users on the internet go and find and search for this IP address, for instance 8.8.100:80, and then using port forwarding, this traffic will be redirected to this server. And if you are a user on the internet and go and look for this resource 8.8.100:53, using port forwarding, that traffic will be redirected to this other server. And if you're a user on the internet and want to reach this resource 8.8.100:21, destination port 21, then this router will redirect this traffic into this server. The same happens for this. If you want to connect to 8.8.8.100 at destination port 25, then this router will redirect this traffic to this email server. And if you wanted to reach this IP with this destination port, this device will send that traffic to this device, internal device. And you probably want to set up this other port, so this device, this router will redirect this traffic to this other device. So if you notice, you can publish this amount of services on the internet using one single IP, using port address translation. In this case, this particular feature is known as port forwarding. Now, in order to configure port forwarding, you're going to use IP NAT inside source and then static, but we are going to use TCP or UDP mappings. We are going to have to set the inside local IP, the internal port number, the outside local IP, and the external port number. You can use the extendable feature as well. So for instance, if you have one server that internally has the IP address 10.1.1.1 and it is providing services on port 80, then you can configure this. For instance, if this interface has the IP address 189.189.189.189, which is reachable through the internet, then users typing in this in their browser will redirect it to this particular internal server. That is what we are configuring here with this example. Now, we have talked about NAT, but usually thinking about the global routing table. But what happens if we have PRFs? We have several options. For instance, what if your inside does not belong to a BRF, so it belongs to the global routing table, and if your outside belongs to a BRF, that is known as NAT global to BRF. It is supported. What happens if your inside interface belongs to our BRF and your outside interface belongs to the global routing table, this is known as BRF to global. This is not really supported only on old iOSs. What happens if your inside interface belongs to a particular BRF and the outside interface belongs to the same BRF? This is known as BRF for overloading. This is also known as match in BRF. You must use this parameter match in BRF when creating your NAT. It is supported. And what happens is if your inside interface belongs to a BRF and your outside interface belongs to a different BRF, in this case you have NAT between BRFs. This is supported as well, but you would internally have to use something that is known as NAT NBI. So in order to troubleshoot NAT, you can issue show IP NAT translation, show IP NAT statistics, and this for a BRF. You can clear your NAT translation using clear IP NAT translation. There is an interesting thing here to talk about, which is the NAT timeout. Let's say that you are using NAT overload or dynamic NAT, and then you are assigning certain resources to a user. So a certain user is assigned a certain NAT resource, for instance, for overload or dynamic. So you are going to NAT this user IP into the internet using a public IP address and a certain port, or in the case of NAT overload. The question is, how long are you going to keep that resource assigned to this user? Dynamic NAT and NAT overload will NAT an address for a specific time. So each private address will get assigned resources for some time. These resources are not assigned forever. So this is known as translation timeout. It usually defaults to 24 hours. So once a user's IP is NATed through dynamic NAT or through NAT overload, that translation resources will be assigned to these users for 24 hours. For some networks, this might be too much. If you have too many users and for some reason your NAT stops working, that might be because you are running out of IP addresses or you're running out of port, TCP or UDP ports. And you might want to reduce this time in order to squeeze more resources. So you can use IP NAT translation timeout and IP NAT translation for UDP, DNS, and TCP. Now there are a lot of other NAT features that we didn't talk about here. We didn't talk about NAT PT, that it has to be with IPv6 and IPv4, stateful NAT, NAT on a stick, NAT NBI. We didn't talk about that. Probably you might want to go and research these topics for yourself. So this is a summary of what we saw in this session. Inside source IP NAT translation, outside source IP NAT translation, static NAT with the variable, with the parameters that we can use. Remember that static NAT is usually 1-to-1, but we can have some variations of static NAT, which is the network variation, where you can have, for instance, you can map a complete 24 set of IP address to an /24 of IP address, or extendable, where you can map one IP address to two IP address, for instance. Dynamic NAT, which is many to many. We have NAT overload, which is, for instance, a lot of IP addresses to one public IP address, or we can NAT a lot of IP address to a pool of IP address using a combination of NAT plus port address translation. We also saw port forwarding, when you can have a lot of IP publicly available services using only one public IP address. We also saw NAT timeout, which usually is 24 hours, but you can change this time in order to get more resources freed, and then you can use NAT and BRFs. We have several options when using NAT and BRFs. You can have global to BRF, BRF to global, match in BRF, and NAT between BRFs. So that's it.